So my usual starting spiel, I record these. I put it up on YouTube and Twitter within an hour or two after we're done with the meeting. If you're not comfortable with that, please leave now. I reserve the right to moderate, never had to do it. Anything to do with compilers and language implementations and runtimes is fair game. And after that, it's open mic and anyone asks a question anytime. Although specifically this week, we had a request to talk about implementing specifically string concatenation in C2, but just compiler optimizations in C2 in general. And there was an obvious misunderstanding of sort of the right way to use C2. And independently, I haven't, compiled and built C2 in a decade, so I don't have a running build to go test and debug with, nor do I know what's happened in the last, 10, 15 years to C2, other than I grabbed the source code, a couple weeks ago and stared at it, and it looks roughly the same, give or take modest amounts of things. It hasn't moved very fast. And every time somebody new shows up, I'm going to stop and just record things for a second. And then so a little more opener here. Last week we ended with talking about doing string concatenation optimization in C2, and there's an obvious sort of misunderstanding of how to use C2 sort of at a high level. There's the obvious low level of I have to connect up these edges and nodes and wires because that's a graph IR. That's what it is. And if you make a mistake there, shit hits the fan, and typically a compiler proves true is false and then proceeds to delete your entire program, having shown it's entirely dead or something stupid. So assuming you get past all those hurdles, the misunderstanding or the not observation was the optimizer is really good at removing crap code. So your goal isn't to, when you're making an optimization here, your goal is not to clean up every possible pattern match variation of string concat. It's to do the minimum necessary the optimizer is not already going to do, and then he will clean up all the crap code that's left behind. And that's that's what he does. And he's really good at it. Okay, and then there's something in chat here from Zen who had a question last time, and he had said, "Hey, here we go. Look at this." And I asked him for exactly this kind of a thing here, which looks a whole lot like a badly laid out bit of C2 IR with a whole lot of extra edges. Like you can get rid of the con top edges; they're never any help. And Ludovic, you have your other name up. Let me go back to the link in the chat there. And otherwise, seeing way too much junk going on. All right, let me finish up here, and then I'll stare at the code. Is that if people understand the rules of the game of how we play in the metagame here in the chat, right? It's all fine. And so Zen, I'll let you, if you want to, start talking about what you're trying to accomplish. I know somebody else was interested in doing that too. Charlie Gracie was trying to do this thing too. I have no sound from you.
I missed what the topic is.
We're going to talk about C2 optimizing string concatenation.
Yeah.
Just to start with.
Okay. Yeah. Let me first of all, let me introduce myself. I'm the software engineer at Amazon. Now I would like to talk about these ongoing projects in our company. We try to optimize Java, or more specifically C2, on the string operations. And this node is some kind of summary what I'm doing right now. So first of all, I observe that there are many substrings. There are many string objects from substring. Because after JDK7, they changed the implementation of substring. And previously, actually, they return a a string. They return a string with an offset. But after Java 7, they changed it to always return a brand new object of this substring. And if you don't use it carefully, actually you will end up generate a very long or many strings from this substring. For example, you can see that I list 3 idiomatic use of this substring, which is they look quite simple, but actually when I look at the code, when I look at the code, I found that there are many people use in this way. Probably they don't use that. Probably they don't use that as dumb as this looks like. But you know, if you consider the inlining, if you consider constant propagation, you will find that some people just use this kind of pattern. For example, let's see that this is the first example here in the document. It's called a string and start with pair. And is there anybody? Hello, everybody. Can you open this document? I just shared on the hyperlink. Yeah. For the first one, it's look like quite like this. So, I mean, so let's say that this string is pretty long. This input string is pretty long. Actually, it creates a substring from the with a minor shorter, a little bit shorter than the previous one. But you know, they just use start with to compare some kind of prefix. This is the pattern. The second pattern is like this.
So Zen, you know, there's both enough to go on from here, and also your diagram that you follow through the substring.md, that markdown shows that we're missing the piece that's necessary that C2 will need to do the optimize. The right way to go is optimize this thing. So I would say don't go any further. Start with the first example. Assume S is a megabyte, and we don't want to copy it just to test the second character.
Yes.
Let's go from here.
Okay.
I also have a quick question. Wouldn't it be easier to understand and follow if you guys shared the screen with the diagram and kind of pointed at the right positions in the?
Yeah, we can go. It's a simple link to follow through, and people can then scroll and stare at it their heart's content.
Right, but the mouse pointer to say what section of the document you're talking about.
All right. Yeah, fine. Hang on.
Actually, to be honest, this is the first time I use Zoom to have like a live meeting.
Okay, I gave you the option to share, although I can share if you want, because I know what I want to do here with this example, which is do one quick step of inlining, and then then we need a new diagram. So I don't want to go very far here.
Here, I just shared the screen.
Yeah, scroll down a little bit, please. So, okay, so there's a bunch of things here about looking at C2 graphs that'll help. The first is that it looks like you did an auto tool, but no one ever cares per con top, because that just, it's like a null. It's just like, hey, nothing here. You get rid of all those black edges for con top, it shrinks a lot of crap out. The next one is you have projections following a call. Don't even put the little purple projection edges, abut the nodes directly against the call, because that's semantically what they do. And that just tightens the graph up a little bit. It's fine. So graph bits aside, what we're looking at here is, you have a substring, and then you want to do a starts with, which obviously does a little bit of a load after you go a little ways in, and an uncommon trap, which I honestly, I just throw off to the side and don't ever look at, because I know I've passed my null pointer check and I don't want to see that. But I claim that the right answer is that you should inline substring in C2.
Inline substring. Okay.
And then look at the next level, because what you want to have C2 see is an array copy as a primitive node, taking from the original to the next with source offset by 1. You know, length sorted by 1, source is offset by 1 because you're doing a substring of 1. And then you do, you know, get first character, and now you have a pattern that can be optimized, right? So the first thing to do is you inline substring, and now you want to do back-to-back array copy optimization and or back-to-back substring or starts with optimization. There's, you know, a couple of varieties of things, but they're going to start with inline your way down to what you might consider a primitive, and I would claim a bulk array copy is one of your primitives, and a new string is another primitive. Making a new array that you've bulk array copied from another one with offsets is the right primitive level, and then go at it from there. Once those have been inline and you can see through to optimize the substring or the starts with call, then C2 should do the rest. Should clean out the extra copy goes away, and the extra noob dies and goes away, and all that kind of stuff happens.
So, but basically, what you are saying is try to inline everything and find a certain pattern in the lowest level. I mean, in the C of node, right?
Right. Stop the inlining at a primitive array copy as a bulk operator that should be a C2 node. So you want a bulk array copy, and I don't know if I had one at Azul. I don't know if you guys have one here. You want a bulk array copy node. You want substring to bottom out as that. You want to have some smarts around new, making a new array that comes from a bulk array copy node. And then you should be looking at, I did an array copy with a, you know, a +1 offset, -1 length, or whatever here, so copy here. You know, you did source +1 on one side to dest with blah, 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 ignoring offsets and, you know, length -1. So this is your new intermediate string is some sort of copy from the old one with a minor offset.
Minor offset, okay.
Right, and then you do a starts with, which is compare the leading bits of the result of the new with another constant string you have off to the side. And now this one, you know, you need a little bit of a smarts on how the compare goes, but the compare should simply say, since I'm an array copy, I'm going to not load from the new, but I'm going to load from the array copies offset. Right, so somewhere in the world, you had a for loop that said load characters, you know, up to the length of whatever your string here is. You're checking for A, I don't care, whatever. And instead of loading it from new at offset 0, which is what I just showed, you want to load it new at the offset given to you by the array copy from the new, which would be at offset 1. And then that's it. The new goes dead because there's no one referencing it, and you get rid of the intermediate array copy, and you simply, and you don't do anything else. You just have to have the new peeked through by the starts with. And then the new goes dead, and that's the main goal of that optimization right there. It's done. So does that make sense then? So it's like silence.
Yeah, I'm reading.
So substring should get triggered because it's hot or because you've declared it. Oh no, it's very small. Small hot methods trolls get inlined all the time. That's all fine. Yeah, array copy node. Okay, fine. I wonder if my version has it. I have an older version on my desktop here, which somehow you went full screen on me, and I don't want you to be full screen. Okay, come on. Here we go. Emacs, that'll work. Just looking at this. So, boom, yeah, I don't have a array copy because that came after the version of the version I have on my desktop here. It's fine. Yes, you want an array copy node.
Okay, I got it. But you know, colleague, Actually, there are like more than one way to do this kind of thing. For example, recently I just noticed that this star width have a brother called star width offset.
Yeah.
So that's why I came up with a new idea. It's like this. I call it a so-called API simplification, because let's say that I don't
Okay,
like
slow down. Slow down. The way that C2 is designed, it'll handle both of these cases pretty much identically with one internal change. There's an entirely separate concept here where you pattern match function calls like the string libraries for common patterns and then replace them with a new pattern at the string level. C2 is all geared about optimizing well below the API level. If you want to optimize at the API level, C2 is not the place to start.
Which place should be work? Because I feel that maybe this is easier to implement.
Okay, so obviously you have to do what you want to do. And for me, I've been messing with C2 style things all my life, so C2 is easier to implement because it will handle all the cases that you're talking about and many others all in one go, and not be limited to strings playing this game. It'll work with integers and floats and double arrays and all other kind of crappy things. And it will handle all the varieties of string ops all at the same time with the same optimization, like 2 or 3 optimizations and you're done. It will cover the entire string library. So I think C2 is easier, but you have to decide what you're going to do.
Yeah, I feel that what you are talking about is the general solution I mentioned
Right.
in the bottom of this note. You can see that there is a general solution. I totally agree with you, but the thing is, if we do it in a higher level, probably we can get like more opportunity or the more opportunity to optimize it. For example.
Probably not.
Oh, here I have an example. You can see this one. I called it the third pattern or third idiomatic use called split and pick.
Sure.
Yeah.
So I'm not going to claim infinitely for everything, but string split of a single character gives you something a little more complicated that walks and tries to build subparts of which you only want part 0. This is entirely doable in C2 as well. At some point you're going to want to do something above C2. I'm not going to say no or never, but I would hit the general case first and then see if you care about the rest of the cases.
Okay.
Somebody who's doing a split on a slash and getting a 0 as opposed to just like a car index of a slash and a substring, I don't know. That's maybe an API change as well. That's easier. Somebody was saying something.
Yeah, I think the biggest problem with this approach when you try to match something on the API level is you need to defer inlining of these methods, but you don't know whether it's profitable or not. And if you start playing these games with inlining, you can actually break other things and not get the benefit you want. And like we looked at similar things, and we haven't yet done anything on the API level specifically because of this issue. Because it's easier to have a general solution on the level of abstraction you have at IR, and not bother about this question whether you should inline or defer.
Okay, so let me ask in this way. This is split. Some people just split a string into a very gigantic string array. Sorry, and they just use like the first one or the first 2 of them. So yes, I feel that if I inline them, if I inline this split, I actually lost chance to do kind of further optimization, because if I don't, maybe I can figure out, okay, this program or this method.
So Zen, back up for a second. Do you have evidence of high volume use of split with constant indexes? Because as soon as you don't inline, you're also not going to have the 0. unless it's a constant 0.
Um,
Yeah, the 0 has to be obvious textually from the bytecodes, which
yes.
it could be. I mean, I don't know. Whereas
Yeah,
I'll claim that string concatenation and the examples you did of substring and this and that, I have seen certainly come out by the bazillions. So before you even head down string split, I do string append, string concat, string substring, starts with, ends with, all those things as being far, far more common.
Oh yeah, for your information, there's like a string concat optimization in C2. They try to recognize this optimization try to recognize string append. Some strings append to the string buffer or string builder, and try to rewrite this kind of code chain to get like a better ideal graph. So that's what they do in C2 right now.
Okay. I'm claiming it's time to build on that work to handle your substring starts with case and maybe some of these other string append variations. And then, sorry, it's my antique cat trying to get in and out of the house. He claws the glass. It's like nails on a chalkboard. Gets my attention.
Well, as far as I know, the string concat and string builder optimization is specifically looking at the API level. So there is a precedent in C2 currently which does it. And I think that's why it looks appealing that you might want to do similar things to other methods.
But I don't think you want to turn off inlining. You want to do this prior to C2 and then have C2 inline the results.
Well, but then there's this question, inlining gives you some facts and you may not be able to optimize without seeing these facts.
So the other, you know, sort of the bigger problem is having C2 go through rounds of inlining and pattern recognition and doing a high-level pattern and then inlining and high-level pattern and inlining. That one's sort of much more difficult to get right.
Yeah, but then you have this kind of pass ordering problem. Like, what if you inline something before you had a chance to see the pattern?
Exactly. No, that's what I'm saying. You have this. You have an ordering problem there. Whereas the general solution that I'm talking about is inline everything till it bottoms out, and then you typically have canonical obvious patterns in the graph, like I just wrote there with array copy being used by a for loop that's just walking through contents, and it should just peek through, and then the array copy goes dead, and you delete the array copy.
Yeah, I understand that, and also, you know, right now I'm doing this kind of optimization in late inliner, not in the
I'm gonna
inliner.
stop the screen share so we can get a full view of people here.
Okay.
If people go ahead and finish up, and then Arthur wanted to say something else too. So where are they?
Oh, I actually didn't. I
got a hand raised from somebody.
Yeah, I accidentally clicked on that while trying to open the chat.
Yeah, I know that. The thing is, you know what? I'm doing this kind of optimization. I call the API simplification optimization in late inliner, which means if I cannot detect this kind of certain pattern, I give up and just inline the manually. This kind of like a second chance.
The problem you have is you don't have a canonical, you don't have a monotonically improving solution. So you take sort of potluck that you've inlined sufficient to get the constants down that you can see path.split of a constant string with a constant index for the array content that you're pulling out. If you don't get that constant, you carry on inlining something. And then eventually, perhaps the right inline happens, and you could have had the constant if you didn't inline the right order. In general, there's no way to do that. There's no way to optimally know that you can inline in some order such that you'll magically get the constant you need to trigger your API solution. Whereas the general solution will get it every time.
That makes sense. And also for your information, I did this general solution at the first place. But I feel that, you know, when I did it, I feel that I'm facing too many cases. As you said, I did it in wrong way. So I feel that, okay, this is too complex. How about I attack this problem in different way, in like a higher level? So that's why I propose this kind of API.
May I encourage you to go back to the general solution, but trust the optimizer to clean out all the weird special case shit.
Yeah, I understand that.
Okay. In fact, he'll clean up all your offsets through the array copy. Like in the example we were just talking about, the simplest one, you know, the load of a offset into an array that came from an array copy should entirely just fold off of the load math.
Yeah, because you know what? Because I'm now doing it in higher level, which means before inlining. So.
Exactly. Take him away. Da-da-da. Thank you. He's being needy.
Yeah.
And he likes to claw my leg.
You know, because I'm now doing it in higher level, I mean, before inlining, after I change the function call, there's a like a later deprecate function call there. So I have to remove that. That's like a deprecate function call, which is.
Whoa. What do you mean by a deprecated function call?
Because you know, I change the API, I change the function call, I change from the start with to like start with offset.
Right. So if
so
you
which
build
means
the graph,
I got.
Okay, if you build the graph right in the replacement, the old thing dies and goes away.
Yeah, but the thing is, you know, if I want, I understand that I should let optimizers to do the job for remove those deprecate nodes, right? But the thing is, for a Java static code, there are like too many inputs and too many outputs. So
no,
I don't know which one is very sensitive to cut. So
okay. So the answer is you must move them all, or else you're wrong. So you got to cut all the outputs of the old call, or it's just wrong, and the graph should in fact collapse around you and crash and burn. You must cut them all. If you have not cut them all, you have a dependency on the old call that is not going to play well with the dependencies on the new call.
Yeah,
so you route them all from the old to the new, and then the old goes dead.
Okay. Yes, I read your JVM, iterative JVM. Actually, if a node has no output, they will be marked as dead.
Yeah.
So I think that's why you said that I have to cut all outputs from the old node.
Right. So be careful here. The reason to cut all outputs is not to make the old guy go dead. The reason to cut all outputs is because somebody's using that value from the old call. And if the goal is to get rid of the old call, he can't have any uses. So every one of those uses has to be moved to somewhere else.
Okay.
They have to get their inputs from some other place. And you have to choose what that other place is. That's the hard part.
Yeah,
the inputs to the new call, that's usually pretty easy. You have to figure out what all the outputs from the old call are being used by who, and what they should be used by instead, which is typically one-for-one mapped to the outputs from the new call. But maybe it varies according to whatever you're doing. And as soon as you move all the outputs from the old call goes dead. That just happens as a by, of the by thing. But if you haven't moved all the outputs from the old call, you are dead, and dead, broken.
Yeah, okay. I understand that.
Okay. And that may be some of the problem you would have before with doing the API, the general solution was every time you move, if you do any graph rewrites, the semantics have to be the same at some perimeter, and every edge in and out of that perimeter in the graph remained unchanged. And inside, you mutated it. But that meant all the edges, you have to be able to draw a line around some section of graph. Like you have a picture of a graph you're showing in your substringed MD. You have to take a pencil and draw a line around some edge, some perimeter. Every line that crosses that perimeter has to be rerouted internally to something else. But outside, none of the edges changed, right? And that's the semantics of graph rewrite. So if you left anybody behind, pointing, hanging in loose in space or pointing to the old guy, didn't work. You have to cut them all and reroute them all. And
Let's see
when
that's
done, and then the optimizer takes it from there.
let's say that we draw I draw a circle, a region of this node. So you just mentioned that I have to deal with all the lines, right, or all edges. So
yeah, this is one of these like whiteboard, and you draw a circle around some section wherever you decide you're going to optimize.
Yeah. I know that.
Okay.
But after I read your iterative JVM, I realize I have to deal all the outputs. So what about the input? Should I deal with the input as well?
No, you deal with the inputs on your new thing. You leave the old inputs alone, because when the old guy dies, those edges will die too.
Okay, cool. That's cool. Okay. Yeah, that's what I want to learn. Yeah.
And Flavio, you have a different issue. You can't.
No, I just want to say one sentence.
Okay, fine.
The funny thing is, after my optimization, I got like a simple version of start with, which compared directly from the old string, right? But because I failed to delete the old or deprecate function call, I actually leave there in the final code. So actually, my optimization kind of like did the job in like halfway. And so that's where I am. That's all. Thank you.
Yeah. So trolls, I was doing string concatenation optimization on C compilers 30 years ago, but it never, there are only a handful of cases that were common enough and simple enough to do on a regular basis that, and strings. The other one was, I did things with hunting through arrays, looking for a particular named element. That was a common enough one as well. For I equals 1 to n, a sub I is equal to element was a common enough pattern to do something special about. Other than that, I didn't, not in a general purpose language. Special purpose languages doing SQL query and shit like that, yeah. General purpose, string concat was the only guy. We did things with format strings too, but that was another string concat variation.
Well,
some of those you did at the API level, some of those you handed off to the compiler, the optimizer.
You can also view boxing unboxing thing like doing similar way where we where C2 has nodes for value off and the corresponding. We actually did it the other way. We inline all the way and then figure out the semantic from the inline code.
Yeah, that's how I've done those things in the past. Is just inline all the way and then figure out how to do it. Maybe with a node like array copy. And you can imagine, I can imagine a value of, because capital A integer does the horrible cache thing, which screws up all your optimization. Yeah, I hear this is the thing, but the low level approach is truly general purpose, generally without too much grief. Zen missed some key things. I think you got it figured out. It's going to be fine. Looking at Matt's comment there. I'm still of the inline it all and go to low level, and I've done amazing shit at the low level that I got told you'll never get it done, and it worked much better, including all the array looping optimizations on the planet. I was told repeatedly by people, no, leave a fucking loop structure node, blah blah blah, in the graph, and you have to have it, and yada yada. And then it's like, no, I did it from the low level and built it up, and then it worked out better, and it covers every possible kind of loop and all variations and things with horrible entries and non-linear striding patterns and everything else.
Well, I would say that sometimes, at least it looks much easier to handle things on the more higher level.
Yeah.
But
you have
to the point that we can have, to Matt's point, that we can have a high level IR and optimizer. I think in this case, we would end up with basically implementing many of the things, including inlining and other classic optimizations, at a different representation level. And basically, we would need to have two different optimizers, which does not look ideal.
That's where I came from. I didn't want to have two different optimizers. I've been in the world where I've had two different optimizers, in fact, and it sucked because you would be confused why one thing didn't happen in one level, but you couldn't reverse the levels or run them back to back because you couldn't go down and up and down and up. So if it didn't happen at the one level, but you needed something from the other level, there was no way to fix it.
Yeah, basically every boundary like this, it's an opportunity for pass ordering issues.
Yep.
Like if you didn't catch it at one level, well, good luck.
Too bad. Yeah. Now you're stuck on the next level. Yeah. Yeah.
But I see the appeal, and we've seen several problems which we thought about doing it at a higher level, but not yet done.
So Matt, the issue with user-defined, optimizing user-defined containers is that unless you have some sort of semantic assertion that dict behaves like a container, you cannot do that. Suppose you define this code and I've made dict say, upon first entering an A, fire the missile, and the missile can't come back now. Now you want to put another A in here and say, no, don't fire the missile. It's too late. It's done. It's fire the missile, print a log, whatever. You have no semantic guarantee. So now if you say, I want semantic annotations, you have the same problem that Java has for hash code and equals. There is a language written unenforceable spec that says hash code and equals should be compatible somehow, but it's unenforceable. And if you fail to follow the rules, you get fucked up. And if you ask the optimizer, he doesn't to do that, then he doesn't follow the low-level rules of the game, which we all understand. Instead, he follows the high-level semantic rules, which will break at the low level because you haven't followed the semantic rules. Like an annotation is not something a compiler can rely on. If he can validate the annotation, it's a great hint. Go check to see if it works. If he cannot validate that makes sense, cannot rely on it. It's not a provable fact.
These high-level optimizations, are they also not sensitive to inlining? So in this dict example, if those dict assignments were in separate functions or methods, then you would need to inline them to see the redundancy.
Yeah, but you have to inline them anyhow. There was no different, you didn't get any optimization.
Right, yeah, right. So if dicts are built in, then maybe you have a dict assignment node. But if they were user-defined data type, then you have to be careful not to inline.
You have a semantic assertion because it's built in. It's in your trusted code base.
Right.
Well, essentially, it's intrinsification of those. Like you know the semantics of the method.
Right. It's in your trusted code base. Anything in your trusted code base, you can do transformations on like that. Anything that user wrote. So somebody wrote it's user. Somebody added it, including user-defined container. Yeah. If you have a user-defined container, no, you cannot. It's totally dict can be in your trusted code base, and totally it is in Python, and you could do it in other languages too. You could also do it in Java and just say, I'll look at the bytecodes and pattern match. And if you haven't hacked the bytecodes, you didn't hand me crap rt.jar, then I trust hash table, for instance. I know what it is. And I'll just do a one-for-one translation to a different, my favorite hash table. Whatever. In fact, I know I've done that, not necessarily here, but in other places. The name was the right name. Next step, bytecodes were the right bytecodes. It wasn't bytecodes. It was some other pattern, but it was some other thing. And then once you decided you actually had the right thing, so that was a hint. You took a hint that said, we could do this thing, and then you had to validate the hint was correct. But then you did the thing. So Flavio, you had a comment that I didn't follow way back before we got wild and crazy on inlining.
Yeah, so that's just something from Scala. We have similar problems with like collections, future, where you have like chains of operations, and sometimes they don't really escape the methods. So I had this proposal of having a fusion behavior that the user can define, but I couldn't make it work with crawl because the hotspot runtime makes too many assumptions about the stack frames, and I couldn't make the changes. Maybe it's not possible. I'm not sure.
This is like, you're talking about stack frames. This is like escape analysis things or something?
No, it's basically, so when you have like this kind of case where you have something that is like a immutable data structure, and you have like a chain of operations where you can say, okay, there's a pattern that I can optimize. I was trying to make that pattern something that the user can define as something that can be optimizable. So the user would define basically a fusion class, and then the fusion class would be invoked if you have a chain of operations in a specific class. But I couldn't make it work because then I have to change the stack frames. I'm calling different methods instead of like the regular methods. And I hit some walls because of that. Yeah.
Wait, this is like you define at the user level some class that has a chain of operations that said if class A does with B action C, and then class C with action D, and down the line. And then when you hit the head of the chain, you want to stop and pattern match to see if you see the remaining of the chain all pile one after another, and then do your replacement.
Yeah, and that would be defined by the user.
Yeah, that looks ugly to do, because the call path is extremely hot and extremely optimized. So at the end of the JIT day, if A calls B and it didn't get inlined, A calls B with an x86 call instruction. And that's a half a clock cycle on an x86. It's one, but only use a handful of resources, so half a clock. Okay, you cannot raise the cost on that in any significant way. So if you intercept every call to say, and oh, check to see if this pattern holds, you lose by like an enormous orders and orders of magnitude. Cannot be done.
Yeah, the cases that I was proposing to optimize were cases where I see the pattern statically. So we have, in our case, it's more future composition at Twitter. We have, like, for instance, future call, and then you have map, flat map, filter, multiple operations, chains. Right. And we can see them like statically in the same compilation unit. And actually, I don't need to actually
if they're in the same compilation
and etc. So I was trying to avoid that. And okay, if it doesn't escape, I can apply the fusion of these operations.
Right. So if they're in the same compilation unit, you have all the parts at compile time, you should be able to do it. And it has nothing to do with stack frames. That's what I was confused about stack frames. There's nothing to do with stack frames.
It was a limitation. At least I spoke to some of the Growl folks, and they said they were not sure that was possible to do. But basically, where I call, for instance, list.map, I would have to redirect that to another method call. And I couldn't make it work with like the constraints. Maybe it's possible, but at the time I couldn't make it work.
Okay. In theory, it should be possible, although if any of your replacement code throws an exception, maybe because the original code would have also thrown an exception, doesn't matter. You have to decide what the Java semantics are, because you have replaced them on the user who hasn't necessarily seen what you did and why. And if you do that at the C2 inlining level, somewhere in there, you know, what you basically said is sometimes, not always, sometimes I'll replace A with B. And that, you know, that means from a user point of view, if I give you crappy things and it's going to blow an exception, sometimes I get my list.flatmap.whatever like I expect, and sometimes I get, and also it got rewritten by some user thing, and now I have an exception inside the rewrite code, and I don't trust the rewrite code, and I've never seen this rewrite code, and maybe it's wrong, right? And now I'm busy, you know, debugging the rewrite. And here my list.flatmap had multi-threaded thread safe behaviors that I understood, even if they weren't happy, they were understood. And now I don't. So I'm just warning, that's a warn, not a you can't do it.
Yeah, I think that's a valid concern, like especially for lists. I didn't design that for lists, for instance. That was the example, but that wasn't the main target for me. It was basically future composition. And it's something that if we were able to do this kind of optimization for futures, it's something that we can do safely because of the nature of the API and how we implement the future. But yeah, makes sense. It's a valid concern. Yeah.
There's the, I'd like to say there might be something, I'd have to see a concrete example. There's a C2 plausible things in some of these cases. Like Zen's case of string split is right on the edge of where I would say it'd be tolerable for C2 to do a general solution. And a slightly more complicated version of string split, I'd claim C2 is a poor choice, that it was time to bail out and do that at a higher level. And I don't know what the right, but always, as soon as you do it at the higher API level, you have the general flavor of, I have 2 levels of optimization. I don't have all the facts I need at the high level to do this optimization. So at the low level, it can't be done because I blew something at the high level, and vice versa. And the low level doesn't know how to do it because it's too complicated at all, and so on and so forth, and you suck. For me personally, in programs that I've dealt with, systems, build whatever, H2O and all the follow-ons and things like that, those kinds of patterns I just taught people. I gave them the short version of how to do string split, pick number 0. Hey, there's another version of that. Do this instead for the obvious reason. But that's not a scalable solution. You know, having the optimizer do it is a much more scalable solution if the optimizer has the facts to do it. And there is a distance, a semantic distance that'll C2 covers the general solution. At some point, you're too far up it, and then you need to do something else. And I don't have a good answer there. For like the loop ops for H2O, where the inner loops had to do megamorphic vcalls, I taught the system to clone the loop. But I didn't clone it at the C2 level. I cloned it. Cat, what are you doing again? Get away. Excuse me. He's a very nice kitty, but he's also decrepit. Go. Thank you. There was a thing there where I more or less put down a user annotation to the surrounding system that said, clone this freaking loop once for every possible concrete type of the input arguments, and do a cached lookup on prior clones, because you couldn't clone infinitely. And then that gave me concrete types in my inner loops. Or at least this was the high level goal, some of which happened post H2O and some did not. So there's a way to go forward there. I don't know, I did a lot of shit with stacked futures also, but we did things in a different way, maybe. I hear you. The main thing the H2O did with stacked futures was we could handle futures that arrived at the rate of billions a second, but were also collapsing at that general flow rate. And then we could efficiently final them all and wait and block on them all. That was the key hack. And I can tell you how that worked. It was very stupid and very straightforward. And very non-obvious when I started, but when I ended, it was like, oh gosh, this works really well. And that let us deal with high volume future throughput. And because we did one weight for billions, it was doing big data, so we had billions of whatevers, high volume weights, but not individual weights of low latency, very high throughput. I don't know if that was the right thing for what you're trying to do with the Scala world.
For the Scala case, we do have a solution that is similar to what you are saying. It's called Stitch. Basically, does like a future-like execution, but it batches things. So we can say like get like 500 tweets from the tweet service, and then I do a single call for the 500 tweets to a separate service, and etc. So yeah, and that's working pretty well. We were able to optimize the execution well of that.
Okay, but that's not what you're trying to do now. You have something else in your head now.
Yeah, it's more the future execution. Futures, there's this problem. It's eager, so it's already executing when it's available, the value, right? So because of that, I have to use a compare and swap on every future composition. So you have to add like a new future to the weight queue of the previous one. And that's, I think, really expensive because you are doing all the time, like that's like on every single small step of the computation. Yeah, and that's a problem for us in terms of performance right now. I did some optimizations for virtualizing compare and swaps in Growl. That helps a little, but still it's a problem yet. Yeah.
So in what we were doing with our futures, oh, here's a late arriving person. We would have a single block point, your stitch point, and would be expecting to see, you know, millions and billions of things coming in. And ultimately, most of the futures had completed shortly upon arrival at the queue. So otherwise you have a flow problem. If not, you have a flow problem and you're swamping yourself with work until you die. So you're keeping up, but you want to track it. So I had an array. I cast elements in the array. I looked for prior things that were done in the array. Done things I could pull out and have an empty slot and I put a new guy in, but there was a CAS involved, but it was one CAS, and there was an array search for things that were already done to find an empty slot in the CAS that was typically very quick because the array never got very full because things died at the flow rate that you're producing them at. So the array hunted 4 to 10 elements, found several done things and nulled them out and picked one and threw down the new guy into the null slot. He didn't actually null him as he went. He stopped when he found the first guy and said, done, in you go, toss the old guy out. And so sometimes you went up to 10 or something, but usually within the 2, 3, 4, within a cache line, you found the dude who was done, you CAS'd in your new dude and you went on your way. But there was a CAS per. I guess probably on a single node, we were millions a second and we could have hundreds of nodes. We did 100 once. Where did I come up with billions a second, Brandon? I totally remember that number. I was doing high volume flow testing at various times and was not having any trouble getting numbers, I want to say in the billions a second. I think in a typical computation, it would have been millions a second easily. It's fine. Memories of things 10 years ago.
Yeah, going back to the example with substring, I looked what we generate here, and actually the pattern after all the inlining is a little bit more annoying, and I think it's very demonstrative of the problems you see when you try to do this approach. So
yeah.
The thing is, there is if the substring we have is an empty string, instead of allocating a new array, there would be a load of one empty string array values, and then there would be a merge of new allocation and like a constant array. Like it can be done. In our case, we would do full redundancy elimination and jump threading, so we separate the paths, but it's not as straightforward as it seems.
I claim I just threw up a whiteboard. I have no idea if people can see this or what I'm doing here. So this is probably actually a bad plan. So there was a thing here. So someone says, hey, I have a string. I can't do a text here, right? No, go away. Yeah. Go away. Oh, there you go. Some string, and I wanted to do a null check on it. So this is not going to work well here. Let's probably something here. What do we got here? You did an if null, right? And then you had to do something, and else you wanted not null, but we wanted to empty. And then you wanted to do
the initial
string.
Well, the initial string needs to have one character, so a substring is
valid already. You already have a null check on substring. Oh, I can't edit it when I'm done. Oh, look at that. Okay, that's interesting. Yeah, right. And I was trying to draw things. I haven't thought this through yet. And the real answer is I need to not do this right now until I can do it on a piece of paper. So let me abort here. I think there's a plan that says it's that whiteboard's usable, but I haven't got it figured out because I do this kind of crap on a piece of paper all the time. Where I draw a graph like this, much more freeform and quick, and then I get what edges need to happen. And then I go ask the optimizer or the compiler what the edges really look like, and I see I've missed some, just like you said. Hey, I have to have a null check or a length check. And then there's some diamond that says I get left or right because it was null or not. And so these optimizations usually have a few extra parts to them and not so obvious. In the case of I had to do a diamond for length 1 or 0 or something, hopefully frequency takes works, and you just cut the offside, the null side, and the less than one side, and carry on.
Well, it looks like if there's no nested profiling, it looks like the case of one is executed somewhere in JDK code, because just this simple test, I see both paths generated.
Can you write some Java code or a piece of paper and throw it up on your video? This is like, I want a concrete example, because this is how these things, you never remember all the details until you sit down, and then you have the hard problem in your face. And then you come back to this chat and it's like, something bad happened. That doesn't help me any. But I remember there being always something bad in these cases that was harder than it looked like. But you have to kind of bring it up and say, oh yeah, I had a null check, I had a length check, I had this check, I had that check. If they failed or succeeded, it went left or right, and they had a lot of diamonds that messed up control flow. And
well, I can try to reconnect through laptop and then type in the chat. Do it in a second.
Oh, okay, I see. You're on a phone or something.
Yeah.
Yeah. Fine.
By waiting him, so can I ask what's the meaning of diamond graph or diamond?
Diamond control flow.
Uh-huh.
A short sequence that goes left and right, and then just merges again.
Short sequence code. Okay.
And, you know, an if test that said, well, here. So here's a piece of Java code. If predicate P is true, there's a 2, else a 3. That's a diamond. So if I assign that to variable X, I have a control flow in the graph that consists of a diamond control flow that merges a 2 and a 3.
Yeah, I understand that.
So if I do substring on a length 0 string, and I do a substring of 1, there's a diamond where he does something different on the 2 halves of the diamond. One of them, he gives me a array copy of length -1, and the other side, he probably says, I throw an exception, or I have gives you an empty again. I don't know what you do substring. What's the spec on substring of an empty string when you ask for length 1? You get an exception. It's probably what you do.
Yes,
if you have an exception, you don't really have a diamond. You have a break off. Those happen all the time, and don't really mess up the optimizer at all. But that's sort of the default thing. You just have a series of tests. Oh, here Arthur's trying to get back in. Hang on. You just have a series of tests that you have to peek through when you did a for loop of looking at characters from an array copy. The control above the for loop will be a series of safety checks that say is not empty, is not null, is this, is that, before you hit the array copy. You have to peek through that set of things, which a load will more or less almost do for free, because he already peeks through control all the time. So Arthur, you back on? You want to test your audio?
Yeah, I will copy and paste into the chats the code in a moment.
And dude, on your profile pic, put a smile on your face. It works so much better.
That looks like a smile from him.
Like a very subtle one.
The Mona Lisa smile. Maybe, kind of. Squint, here we go.
So that's what I see. There is this check for length, and if the length of the original string is 1, instead of creating a new instance, we would use the this one internized empty string. Right. So we would have a diamond, and then at the end of this diamond, the substring would be a merge of this known OOP and the new allocation.
Okay, so right, I got you. So now you have a couple things to do here, of which sort of this is kind of happening all the time. It's pretty obvious. Sometimes the frequency is such that you just cut off length as 1 because it was written in JDK code, it got profiled as part of the inlining, and you just declare def and like wipe it out.
Well, yeah, I would hope for that, but just
okay. Yeah, if it
executing this, we see both paths.
Yeah, if it doesn't, you unzip, which means you replicate the code that's in between the pieces. And I do this kind of thing. C2 does this thing all the time. Now, he doesn't necessarily unzip specifically in this case, but you could do the same thing as the unzip.
Yeah, in OLVM, jump threading would do that. I can see what is missing, so we don't handle this. But I think it just demonstrates how sometimes annoying this this code is, where there is this one case which is not the general case, which easily is.
It's the same with autoboxing. The capital A integer cache blows up all the. I want to peek through the autobox and get rid of the autoboxing and just get the raw thing. And you have to like peek through the cache, and then you have to compile the semantics of the integer capital A integer 128 cache, or else he thinks it's just I'm loading from some array. Who knows what it contains, kind of thing, and it's a pain in the neck.
Yeah, that's exactly what we had to do for boxing for the cache array.
You put capital I integers cache in your trusted code base. You have to agree that you understand the semantics of the capital integer cache. So here I would say that you need to unzip, and that would do the job. And in fact, there's a little optimization on top of that, which because you have a length of 0 and length of 1, and C2 does this kind of thing too. He sees that there's if I do a length of 1, I will never do length of 0. So he'll do a thing there already.
Oh, actually, it's length of different strings, and these paths actually correlate. If the original string is 1, then the substring will be.
Oh, yeah, I see. And 1 is a length of 0 right away, and 1 is whatever the hell -1. No, you have to unzip. You have to unzip it.
In addition to that, yeah, I think we need to see that the substring length is. So to see that the condition of the second check correlates with the first one, we need to be able to see that it's. Yeah, we need to
start right at the second check. You're asking for the length field is equal to 0. If you look backwards, there's a phi function of the two base strings. So you push the length through the phi.
Yep.
This gives you the length of either side. One folds to 0. One folds to length -1. Now you have a test of a 0 and you have a guaranteed 0. You have an opportunity to go unzip it at that point.
Yep. Well, all doable, but.
Yeah, well, I'm claiming that this case should be done. Now, I also claim that C2 will almost already do this because I know the hell C2 pushes loads up, including loads of length, up through phi functions, specifically if you can see a constant on the other side. He will look and say, in general, he does it pretty aggressively, looking for any number of opportunities, a known length or a prior length, because people do copy the length from one array to another through an intermediate variable before they make new allocations and use it as a trip counter on a loop. The length in particular of arrays is aggressively upwards hoisted to peek through new functions, to peek through new array, to peek through array.length, to peek through plus and minus constants, and prior outputs of prior for loops and shit like that. There's a bunch of places where I push hard on array length because that one's just too common. The new array is the same as the old array, plus or minus a constant on the length. I totally peek through those. So I would claim that that would happen here, sort of straightforward. I think right now in C2, I don't know, but I suspect it would right now in C2 peek through that already. This is LLVM, isn't it? Yeah, LLVM should do this. I mean, I don't know what they do, but I would suspect that you do this.
Well, in this case, what I see, we're missing one part where we should do partial redundancy elimination on the load. We don't do this because I think because the fact that the load of a length of a constant is known, we just don't have this fact. Just something I know about. We need to plumb it through.
Fine. Yeah, you have to go hack your yeah. C2 does the thing it does because it replaces partial dependency elimination, and in my opinion, it does a better job. The two are incomparable. Some gets one that the other does not. Either way, but the C2 version, I did this test long ago as part of my PhD. It way the hell stomped PDE all the time. It got way more facts. That's why I like what C2 does in that domain. But it's not a perfect replacement either way. Okay, what else? Too quiet, too long.
Well,
drawing diagrams.
I can share how we how we approach the string concat optimization since it's on the topic.
Yeah,
and this is something I'm currently working on.
Yeah.
So in our case, instead of looking at the API level like current C2 does, we do this after inlining everything. And,
yeah, C2 doesn't look at the API level.
Well, but what currently is in C2 in OpenJDK, this optimization looks at string builder methods.
Okay.
So in our case, we do this as extension to escape analysis. And what we already have in escape analysis, we compute the points to graph of unescaped objects, and we optionally track exact state of unescaped object. By exact state, I mean we know every value in every field, and we use this in order to basically scalarize allocations. So if allocation is used as a deopt value, we can produce symbolic description of this allocation using this exact state. In cases where we have array copy initialization, or in general we have arrays, we may not always be able to have an exact state describing every value. But instead, we can have symbolic state where we know the sequence of instructions which produces the initialized state of the object. So if we have some array which is initialized either by storing into some offsets or through array copies into the array, we can track this as initializing state of the array. Then on top of this, when we see an array copy into a newly allocated array, this analysis will try to forward the initializing instructions of the source array. So if both arrays are tracked and unescaped, so we know their state, it will try to forward the initializing instructions into the new array. This way, we know how to initialize the destination array without referencing the intermediate array. And now this analysis helps us to see through all these intermediate copies into intermediate arrays to see the actual source of the data coming into the array. And in the end, we can replace these, we call it Realic array copy, where we basically reallocate. We create a new array of different size, and then we copy contents of other array. So by seeing through these reallocations, we can at the end produce the sequence which initializes the final array, which escapes with the initial sources which initialize this array.
Yeah, this is the general solution that I was promoting to Zen. I did it at Azul as well in C2. That was well along that path.
Yeah, so at this point, like it's still in progress. We can handle. There are several parts which are somewhat tricky. So when we see an array copy into a new array, we need to make sure that everything we forward through can be forwarded without modifications, so it's not trimmed in any way. So let's say we had an array of larger length and we copy it into a smaller, then we cannot simply forward everything which was put into the initial array, because this array copy can trim some of the content. So this is one of the things we need to track.
Yeah.
Another thing.
Trim the length. You leave an array copy in the graph, in the IR.
Well, I mean, let's say we have
your escape analysis. Yeah. Okay. Fine. I don't know.
So let's say we allocate an intermediate array of len, and then we allocate an array of like half len. Then we cannot simply forward through all the initialization which happened to the larger array into a smaller array.
Yeah.
Because some of the initialization can be trimmed by this final copy.
Yeah. Yeah. No, I am thinking of what I have done, which was something like have the second array copy just had a length that was modified, and therefore it only took portions of the first. But I didn't go to the next step of saying half of the first one is dead, so I want to cut the first one in half or something, and then start killing some initialization bits.
Well, the simple case when we just copy array as a whole, it's easy. We just take all the initializing instructions and forward them.
Right. And if you copy it plus or minus one small constants, I would claim that you wouldn't make any mods other than trim the length. But if you did a half Z's, you might ponder if there was a double Z's elsewhere that you could kill half of it or something. I don't know. So concat people hit that, which I did not do. If I do concatenation of A plus B plus C, and I had a bunch of string copies that did non-overlapping extensions, and then trimmed it again, you'd like to claim the other halves are all dead, and I did not go there.
Yeah, this is something which I haven't yet solved or thought through, but copying arrays as a whole, this is what we have right now.
Yeah.
Another aspect to care about is if we keep this kind of symbolic state, we need to make sure that nobody modifies the memory which we copy it from, because you can have an array copy from some other array and then store into the initial array, and then try to propagate that from intermediate array into the dest. So you cannot forward through if somebody killed the initial location you copied from.
Yeah, so C2 does it with, ustef edges, and it's all fine. Wouldn't have a problem that way. Nothing to do with multi-threading, right? You're not talking about somebody on multi-thread hacking.
No. It's it can be in the same code.
Yeah, this is C2IR with just an edge that you weren't allowed to.
Wait, does it mean that you express aliasing information explicitly using edges in the IR?
Yeah.
Okay.
Not in such a tidy way. The memory edge is serialized, and it can be broken into provably disjoint equivalence classes. I'm looking for equivalence classes. So you have a memory edge. It is an equivalence class by itself, by definition, and therefore you can do what the hell you want with that piece of memory, and it doesn't alias anyone else. The limitation, of course, is that it's an equivalence class. So if you can't prove non-aliasing on subports of an array, which not a lot of work is done here in C2 for that, then you only have one edge and things are just single threaded through. And then periodically, there are a couple places where we do the Oracle style of analysis instead of the equivalence class, where we peek through several things in a row, but you have to do the whole transformation all in one go. You have to be able to see the entire food chain you're peeking through and verify there are no outgoing edges exactly playing, extra users or whatever you want to talk, however you want to name them, to do that kind of a thing. It happens in times in C2, but it's not, it's limited in arrays because of the lack of alias information precision. We get for free if you have a dumbass, no one's using it because you have no other outgoing edges, no other uses. And so you can just count, hey, how many uses you got? You got one, I must be it. And you go backwards, how many uses you got? One, I must be it. And you do that. And that
by uses, do you mean like memory edge uses or any
memory edge?
So basically, yeah, you have this aliasing expressed in the graph.
Yeah, aliasing is expressed in the graph, yes. Except that on the memory edge for arrays, it's very coarsely expressed.
Yeah, in OLVM, there is an analysis which essentially builds the same thing. It builds def use chains for memory, but it is analysis which is computed on the side, and like you can query it. And then if you modify something, you may need to recompute the analysis.
This is why I like the C2 version. It's always up to date. It's always correct. In the case of arrays, it's not necessarily, and you cannot not look at it. You can only look at it because you can't look at the prior def without actually walking the aliasing edge, which is also the memory edge. They are the one and the same.
Well, the problem is now every transformation you have, you need to worry about it and know how to modify this. And if something was not modified properly, like good luck debugging it sometime like 10 passes later.
So okay, see, let's separate out debugging C2 from graph rewrites from the effects, right? So if you screw up a graph rewrite, that you have failed to do the right transformation, semantically correct transformation, the typical fail is in that pass because there's only a handful of passes, but maybe 1,000 transformations on the graph later. They are, however, deterministic, and you can binary search them down. So this is C2. This is how you debug C2 broken graph transformations. If I did one and I do my test, everything's correct, I make my new transformation, I do my test, something breaks, okay, probably it's the new transformation. How the hell did it break? Okay, the same transformation ran 1,000 times without breaking. How do I find them down? Binary search.
Well, yeah, my point is you just have more things to care about when you're ready to transform.
I have done both style compilers. Way the hell less things to do with C2. In my personal opinion, everyone's got their opinion here. My personal opinion, way the hell easier in C2 than in the endless sea of different transformations you get out of an LLVM style, which is why I did C2 the way I did. And I'll claim it is still in business 25 years later. And I guess LLVM is as well, so fine.
Well, at least in my experience, I would say the most nasty bugs I've seen is when there is some smart pass which says, okay, I would update the analysis correctly instead of just dropping and recomputing. And then it does it subtly wrong. So now you kind of have the analysis, but it's bogus.
Yeah. Right. And C2 doesn't do that because it doesn't have that analysis. It has
well,
only the graph.
But you have it in the graph. The idea is the
graph.
same.
The graph is only the entire semantics of the program. If you bust the graph, you busted the whole program. So the fails, in my opinion, come a lot faster. They can be subtle, yes, but they come a lot faster because he takes your broken program and begins transforming it again according to the semantics of the broken program, which typically involves him proving false is true and eating the entire program up.
And obviously there are benefits of because it's all expressed in one graph and you don't do this kind of recompute, throw away. Well, it's much faster.
It's also, I'm claiming a lot simpler, but like I said, you got your opinion, I got mine, it's all there.
Yeah.
I claim you have to live with C2 for a long time and know and do transformations on it on a regular basis for a while, and then make the claim left or right. Because I've done it both ways, and I don't know that you've done heavy C2 lifting.
Yeah, no, the most I did, I read the code and tried to figure out like how C2 does something, but I didn't hack. So yeah. That's true.
Play the game the other side, and then come out and stand up and say, and I like this version because, as opposed to theorizing, it must be worse, it must be better. Because the shoe is always greener on the other side.
Oh yeah.
You haven't been on the other side, it's hard to tell. This is the devil you know versus the devil you don't. That's the right paradigm here, or whatever.
Yeah, Cliff. So for the conventional compiler, that's what I did to debug a compiler or optimization bug. We just binary search for those optimization switches, and binary search then pinpoint that, okay, this optimization made some mistake. So I can focus on this optimization alone to pinpoint which point of code is wrong or is buggy, right?
Okay, so I have a sequence of events I go through if I don't know what's broken.
Okay.
Right, and one of them is I find a compilation that is broken. So there's a binary search on which compilation number contains the broken whatever. On and off, left and right, turn it up and down until I get it down to just this compile. Yes. Typically then I start turning off inlining in that one compile using, these are all compile flags that have binary search like capabilities, both which one that you deal with, like don't compile this guy and then binary search your way around. And once you decide that this guy, yes or no, fails or not, start inlining or not in this guy, yes or no, until you get it as sort of small as you can. And usually at that point, you can look and see it has to have been something here because it was something you did recently that broke it. And you can start at it and start to sort from there. If I'm in a single compilation unit and the graph breaks somewhere inside of it, then I start binary searching on the set of transformations. So the iter pass just does transform after transform after transform off of a work list deterministically. And you can binary search that work list down.
How to binary search it down? So that's the problem I'm facing right now, because the reason I feel that C2 is harder to debug because, I only know that, okay, this phase is wrong, this phase is wrong, but the C2 did a lot of things in this phase. I really don't know which part of
Right.
code.
Okay, right. So if you're in an iter pass, let's say you're in an iter pass, you're in a JC, you're not in an opto, you're in an iter pass, I'm assuming.
Yes. Okay.
Okay. So you get a counter, and I did this a long time ago, and I don't know if it's in the Oracle code base or not. You get a counter that triggers once per pulling an item off the work list. You then run that counter down to whatever point you want, stop, bail out of iter, go generate code and run.
This is interesting. Yeah, I don't know that.
And then if it worked, you're good. Trick. And if it failed, you know, that was your dude.
So what you said is like iterative JVM is absolutely optional. So I can quit at any point. So in this way, I can use I can do the binary search, as you said. I can.
I claim it's optional. There are some cleanup things that at different points in the life cycle, and I want to say I fixed a lot of this at Azul, like the cleanup of dead code. There's a couple things you have to make sure that it's actually optional. It can be made optional. It was optional at Sun, on and off and on and off. I say optional. Once you started a transformation that did something like kill half of an if, you had to complete the other half, which was on the work list. And I went back and forth at this at Oracle, at Sun, and I cleaned it out at Azul, and I've cleaned it out in AA, and I don't know what the current status of Oracle's code base, but it's easy to clean out. It's basically anybody who's doing something more exciting than deleting dead code has to not do anything after you flip the flag. But if you're nuking dead code or dead control flow, just deleting, let that happen. Otherwise, you do get half of an if, and then that's busted. So I guess I don't know if Oracle's there or not, but you can make it deterministic in that way. Once you did something that did a serious transformation, you can abort other than cleaning out halves of dead control flow. You can abort and you're done and generate code and get out and test. And I do this
but you cannot do the same thing for the conditional constant propagation phase, right?
Conditional constant propagation is also optional, but only as the whole thing.
Yes. I mean, you cannot bail out in the middle of the.
You cannot bail out in the middle of it. Yes.
Thank you. This is a very useful trick. I should try that.
Yeah.
Yeah, because you know, I feel that you describe in very high level way. Because, for example, I hear you said that binary search all the transformations, but you know, I don't know how to do that. I get the basic idea, but I don't know how to do that.
There's a high level loop, work list loop.
I know that. Now I know that. Okay.
Okay. Yeah, you just put a counter there, and then you bail when the counter gets above a point.
Okay. Cool.
Yes, and you can automate this. And I had various tools at Azul that would automate finding which compilation unit. I don't think I flipped. I did a bunch of flags there that I was binary. I totally had a tool that the handwritten blah, 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 stupid shell script that would do binary search on the crash and burns to iterate through the compiler ops and then stop. It was both picking the compilation unit, and I want to say that within a compilation unit, it was picking a bunch of things as well. But I think I was picking inlines within a compilation unit. I didn't get down to the point of picking which transformation number, but I knew I could, and I knew it would have been useful. Hey, see ya. Right, and then LLVM is going to have something similar, I bet you. Yes. All of these things, by the way, if you're hacking any of these compilers on a regular basis, these automatic binary search tools, they burn a day of your life to get them to work. They'll save a day of your life every month, maybe every week, for having the tool just like screw around and then pull out the minimal compilation unit and or point where it chokes. Way the hell nice.
Yeah, with LLVM bug point, it's funny that sometimes it can find lots of other bugs on your case. So it would try to reduce it. Yeah. And yeah, it would find bugs because it would act like a fuzzer. And maybe it's not your bug what you're looking, but you'll need to go through all of them before you find your
right. I went through when I started doing this, and I've done this in AA now, and I've done this. I want to say at Azul too, definitely at Sun. Yeah, as soon as you started doing it as automatic, yes, you found a different bug. Well, you fixed it, and after a while, you got rid of the fuzzer generated bugs, and then you were more reliable. But if you're still hitting fuzzer generated bugs, you got some work to do. I claim C2 should be well past fuzzer generated bugs.
Well,
certainly AA was not for 6 months. It's fine. Yeah, it's worth it though. Get rid of the fuzzer generated bug because they always show up elsewhere, just less conveniently. If the fuzzer found them, it was easy to reproduce and easy to get to. So just fix the damn bug and move on. And you'll get to the one you're excited about later. Large test cases. That was probably more like GCC on large test cases. Let me see what this guy is. Mostly it was TCK testing cases. What is he flipping bits on? Oh, he's doing .o files. Yeah, I totally did it on .o files too. God, it was even earlier. Holy crap. I was doing it on .o files pre-Sun. Big compilation unit, you run the optimizer, you get a pile of .os, something broke. Oh, shit. You cut half your .os were optimized and half were not. You ran the test, you lived or died, you binary searched the .os. Very similar to C2 turning on and off compiles using the compile start stop flags in binary search. Dun, dun, dun. All right, it's 11:30. We've been an hour and a half. It's been a really fun go around here. Anything else? I'm going to abort and go ponder lunch. It's a compiler joke. I should totally say abort. Sorry, we had unrelated conversation. Okay, till we meet again. It's been good. Bye-bye.
Bye.